But it turns out those shells alone don't explain all the behavior, especially for elements after hydrogen. What we have to know is that each shell gets divided into subshells. And the analogy that we use here, that I use here anyway, there's a lot of analogies you could use. Let's call it a chest of drawers. Okay. Like a dresser or something, or somewhere where you would be organizing your stuff. Okay. Each of those are drawers. And let's say it's up on something and you're a short person. The first one, the easiest one to get to would be the one on the bottom here. So let's call that 1. Okay. That'll be like the first shell, like we were talking about up here. Okay. The easiest place for electrons to be, the lowest energy place where electrons could be. Okay. So if that electron were to get excited, or if we had multiple electrons, at some point this shell would be full and we would have to just start putting regular electrons in the next one up. Okay? So it turns out if that's our next shell, that each shell has n subshells. And subshells are just like places within that shell. So if we divide it up, you could think of it in our analogy over here, like if we put dividers in the drawers. So if we look over here, it says each shell has n subshells. So n equals 1 has just one subshell. That means there's no dividers here. There's just only one place for stuff to go in that first shell. Okay? So our electrons just have one place to go in there. But in the second one, there are 2 places for electrons to go. Okay? So when we have 2 subshells, they would be called 2s and 2p. Okay? That's just the names that we give to those subshells. And we go in order S, P, D, and F in that order. And it turns out that when we're putting electrons into this second shell, we have to put electrons into this first subshell, and then when it's full, we can start putting electrons in the next one. Okay? So let's take a look. This will make a little more sense when we talk about it in terms of the actual elements on the periodic table. These are the first 2 rows of the periodic table. Here, I'll also get a real one here for us to look at. There we go. So what I've done is just sort of recreated these first 2 rows and taken out the gap a little bit. The periodic table is in order of atomic number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are protons in the nucleus. But since we're still talking about neutral atoms here, that's also the number of electrons. Okay? Remember, in a neutral atom, the number of protons in the nucleus is the same as the number of electrons flying around outside the nucleus. So when I'm talking about atoms of any of these elements, each additional element that we go to on the periodic table has one more electron than the element before it. Right? So whatever I do with boron, okay, I have to do that same thing with carbon, but carbon has one more electron. Okay? Nitrogen has one more electron than carbon, and so on. Okay? Up to neon here, which has 10 of its electrons. Now, what happens, as long as we're within a single row on the periodic table, at least at the beginning here, all of the electrons will go into the same shell. Okay? So hydrogen has just 1 electron. Okay? Helium has 2 electrons, but as soon as we go to lithium, okay, that 3rd electron that lithium has to go into the next shell. Okay? Its first 2 will go in the first shell, okay? But as soon as we move on, it has to go into a new shell. So if the elements in period 1 have their electrons in the 1s subshell, remember, the first shell just has that one place where electrons go, so we just call it 1s. Okay? That's just that one first place. If the elements in period 1 have their electrons in the 1s subshell, that s subshell can hold a maximum of 2 electrons, because anything after helium, right here, it turns out as soon as we go into a new row, we have to start putting electrons into the next shell. Okay? When we get over here, that means we've filled up. Okay? We've filled up a shell, or if we're looking at those drawers, that means that drawer is full, and now we have to start putting things into the next one. Okay? So we can write an electron configuration, and all that is just saying where all of the electrons are. And we're always going to start by listing off the lowest energy subshells, and then how many electrons are in it, and then listing off any additional subshells and so on, counting up until we've got all of the electrons accounted for. So it always goes the name of the subshell, and in superscript right here, how many electrons are in it. So hydrogen's electron configuration is 1s, because that's just the first place electrons can go, and hydrogen only has one electron, so it's just 1s with one electron in it. Okay? That just means one electron. Helium has 2 electrons. Okay? We're still filling into 1s, but now it's 1s2. Okay? So it turns out that every s subshell, okay, and if we look over here, each of these larger shells has an s as its first subshell. So the first time we're filling into n equals 2, we have to fill into 2s. Okay? And it turns out all of these s subshells hold the same number of electrons. Okay? Any s holds a maximum of 2 electrons to it. So when we get to period 2, we have to start putting electrons into the second shell because the first shell is full. So lithium, with its 3 electrons, if we write out its electron configuration, we have to build up, okay, sort of from the bottom, thinking about how am I going to fit 3 electrons into these places? Well, the first 2 electrons will go into the bottom one here. We already said that that one holds 2 electrons. So it's going to start with 1s2. And in fact, every element that's past helium will start with 1s2 because the first 2 electrons will go into that first shell. Okay, that's the lowest energy shell. That's the most favorable place for electrons to go. So as we're counting up these electrons, we're going to start with 1s, okay, and go into 2. Now, lithium has 3 electrons here, so we need one more electron, but it's going to go into the next shell. So the next is 2s, and it just has 1 in there. Okay, 1s2, 2s1. Remember, the subscript number is how many electrons there are. So the 1s subshell has 2 electrons, then the 2s subshell has 1 electron. Those add up to the 3 electrons that lithium has. Okay. Beryllium has 4 electrons, so hopefully you can see what's happening here. We'll start with 1s2 again. Now 2s will also have 2 electrons. Okay. If we go to the next element, it has 1 more electron, but we can never do 2s3 because all of these s subshells just hold a maximum of 2 electrons. It also turns out that when we cross over to a new section on the periodic table, we start going into a new subshell. So here's beryllium. Okay, we're kind of crossing over to the other side of the main group here to get to boron. The reason the periodic table is shaped this way is because of the number of electrons that fit into each of these subshells. So boron will start 1s2, 2s2, but now I've got 1 more electron. Okay, this second shell right here has a divider in it. Okay, so 2s gets filled up, but then when that's full, we have to start putting electrons into 2p. Okay, it's like the other part of that shell. So 1s2, 2s2, 2p1. Boron through neon, those are the ones over here, okay, in the rest of period 2, boron through neon fill electrons into that 2p subshell, each of these having 1 more electron than the element before it. Okay, so carbon, 1s2, 2s2, 2p2, 1s2, 2s2, 2p3. Turns out if you follow the periodic table, okay, if we know the first 2 electrons go into 1s, you can just count elements as you go by until you get to the element that you're talking about. So these 2 are in 1s, so there's 1s, 2. These 2 fill in 2s, 2s, 2, 2p, 1, 2p2, 2p3, 2p4, 5, 6. Okay, whichever one you're ending at. Okay, so all that same stuff, 2p4, all that same stuff, 2p5, all, here, I'll write it out for neon, 1s2, 2s2, 2p6. Okay, so I'll remind you one more time, just so these don't look like jumbles of letters and numbers. What this is, it says that's the subshell, that's the place where the electrons are, and that's how many electrons are in it. So 1s has 2, 2s has 2, and 2p has 6. All you do is follow along on the periodic table. When we go to a new row, we're starting a new shell, so this first big number changes. Okay? When you go into a new section, we're going into a new subshell, so that's when the letter changes. So I fill up 2s with 2 electrons, and then I'm over in 2p. If you look over here, this region of the periodic table over here, this side of the main group, is 6 elements across. And it's no accident that we went up through 2p6 here. As we add 1 additional electron in for each of these elements, that corresponds with us eventually filling up that 2p subshell.